So in 1987, I went to Reno, Nevada for Supercomputer 87, which was a rather large collection of supercomputer experts that get together once a year to talk about what they're doing in terms of high-performance computing, supercomputing. At the time, the major suppliers were organizations like Cray Research, Control Data Corporation, and three Japanese manufacturers, Fujitsu and Hitachi and NEC. At the time, supercomputing was a rather esoteric technology. It was expensive. A machine cost about $40 million a year. They were difficult to program. They relied on something called vector processing versus the kind of scalar processing that was popular on just about everybody else's machines. Their application span was relatively limited. They couldn't do everything well, but they could do some things obscenely well, orders of magnitude performance improvement in terms of what those systems could do. But it was still considered kind of a high priest of technology. I don't know if anything of this all sounds familiar to the people here, but the parallels are interesting. But the reason I mentioned the 1987 conference was the swag they gave out, and the program planners, encouraged by Cray Research, made sure that everyone that walked through the front door got a mouse pad. Now, for those of you who aren't old enough to remember, the Mac came out in 1984, and not very many people used mouse pads back then. And certainly supercomputer programmers didn't. They were used to black screen with green letters. And by giving out a mouse pad at a supercomputer conference, the message was delivered by Cray and the supercomputing community writ large. Supercomputing was for everyone. It was no longer going to be in the realm of the select few, the esoteric programmers, the organizations that were interested only in the highest level of performance and were willing to pay just about anything to get to it. I think there's a parallel here. I think if they were giving out the 2024 version of the mouse pad today, I don't know what it would be, but I think D-Wave would be one of the companies at the forefront in terms of moving quantum computing from the hands of the few into the hands of the many. It's time to really start to understand that quantum is no longer an interesting research activity, an interesting new way of doing computing, much the way that supercomputers were in the 70s and 80s, but they have practical applications across a growing and broad base of applications today. And so what we're going to do is kind of walk through a study that I did, completed literally, I want to say a week ago, to really just try to explore really what's going on in terms of business process optimization. And the key here in all this is that we're not talking about the science and engineering applications that a lot of the quantum computing community is targeting right now in terms of looking at things like low energy calculations of molecular dynamics, some of those other more esoteric processes. It's really, in some sense, looking at the business process world. What can quantum do to the wide range of business users, specifically in their optimizations process, to make their particular business processes more efficient, generate competitive advantage, find new ways to initiate cost savings, maybe even reduce things like time to market and such. So that's really what this talk is about today. It's not about the esoteric portion of quantum, it's how it has started to become a much more widely accepted option for some of the more compelling and interesting business processes out there, specifically centered on those looking for QC-based optimization opportunities. So we're just going to kind of go through this. Now, I'm with a company called Hyperion Research. My name is Bob Sorensen. As Murray indicated earlier, I'm one of their chief analysts for quantum computing. And what's interesting about this process is I didn't come to this as a quantum computing guy. I came to this as an advanced computing guy, always looking for the next pointy end of the spear in computational capabilities, whether it be vector supercomputing in the old days, or if it's GPU accelerated computation, or what's going on in terms of generative AI for science applications at scale. So we're always looking at the pointy end of the spear for advanced computing and its end uses. So we don't see quantum as a standalone island. We see it as yet another opportunity for end users who have compelling workloads, who are looking for interesting performance gains, to find the systems and the technology that serves those requirements. So we look at quantum a little differently. It's yet another tool in the toolbox. It's not a standalone technology, not a standalone island. So we did this work in conjunction with D-Wave, and I point that out, and I use the word in conjunction rather carefully because D-Wave was gracious enough to sponsor this effort, and they made literally no attempt to really try to guide the results or I don't want to say bias, but influence the findings. They saw the results last week, and they basically said, looks good, present away. So this, while funded by D-Wave, was a relatively objective and independently conducted study by Hyperion Research. I'm just going to jump to the executive summary. There's an old rule when you brief at the Pentagon especially, they say that the only way to do a briefing is tell them what you're going to tell them, and then tell them what you told them. So that's really the agenda I have for today. So let's just jump right to the executive summary of some of the things that we found when we conducted this survey. Well, the bottom line is there's a wide range of quantum computing-based optimization activities currently underway in the commercial sector across the 6 major countries that we surveyed. Now, we really went out and we talked to about 303 different commercial organizations to explore this particular opportunity. One of the things I like to do when I do a survey like this is tell you what the completion rate was. So to reach these 303 organizations that said, yes, we have an ongoing quantum computing-based optimization process within our organization targeted toward business applications, we only had to go out to about 695 different potential respondents. That means we're getting at about a 43% completion rate, which I think indicates that there is a wide swath of organizations out there already kicking the tires when it comes to QC-based optimization opportunities. Now, what I want to stress here again is that about 60% of the organizations we talked to self-identified as mixed or primary enterprise shops. They basically said, yes, we have some HPC capability, some advanced computing computational in-house capability or through the cloud perhaps, but we identify primarily or at least partially as an enterprise organization. About 38% said, yes, they were pretty hardcore HPC, and some of them were a mix between either research-based organizations or production. But the key to this is this was primarily an enterprise-based kind of exploration. What we found there is that based on this survey of these 303 organizations, about 21% have or plan to have within the next 12 to 18 months a production level use of quantum computing to address one or more of their important business processes. And that's actually a 50% increase in that number when we did the survey back in 2022. Leading areas currently under consideration: finance-oriented optimization, supply chain management, manufacturing and factory processes. And when we asked about what's the business-related incentive that you turn to quantum, the key results there were enhancing business processes, increasing revenue, and driving innovation. See if I can get that there we go. Some of the greatest organizational drivers inside the company. What made this happen inside the company? What we found was, it shouldn't be of any great surprise, potential performance improvements on key workloads. But what was important, it was strongly backed by the technical staff in-house as well as the senior management folks. So the bottom line is the C-suite has already started to figure out this is something that we need to be doing, and we're going to support this, whether it be through budgeting or personnel commitment or other areas of research, of resources to do this. So it's definitely something that not only are the IT staff and the subject matter experts within the organization saying, hey, this is a really cool thing, let's look at it. The senior management is already starting to get the message. When we asked about the financial prospects for what QC-based optimization can bring to the table, what we found was the most common expectation for a long-term annual commitment. And I had to define long-term because we'll see later I have some graphics about what are you planning on spending this year. But we wanted to jump forward and say, okay, once you have a steady state operation, once you are kind of in a production mode where things are just kind of burning and churning and you're not really in exploration anymore, you're just at steady state, what do you think your annual commitment will be to support those QC-based optimization efforts? And I'll have some more detailed numbers on that coming up. But we found about $3 to $6 million on an annual basis. But what we found is when we asked them about what they anticipated return on investment was based on that annual $3 to $6 million investment, we came up with an annual return on investment of about $60 to $65 million on average. And really what that does is that leads you to an ROI of approximately between 10 and 20 to 1. So there is some pretty high expectations within the survey respondent set that every dollar you spend, you may realize at least $10 to $20 worth of increased value to your overall business process. Now, if you just do the math and you add all that up for the 290 companies that we spoke to that answered these two particular questions in a way that we actually trusted them, that comes out to an annual revenue increase of about $51.5 billion. This is just 290 companies out there. So if you want to take that $51 billion and multiply that along, say, you want to say maybe the Fortune 500 or the Fortune 1000, you start to see some significant expectations for the process of QC-based optimization and what it can mean to some of these large businesses. And based on those rather optimistic expectations, you can see here that most of them do plan to move forward with one or more of their current optimization projects. It's interesting that when we ask them, how many do you have going on right now? Is there one project? Are you looking exclusively at, say, maintenance scheduling? Are you looking exclusively at logistics for transportation? The answer was no. We're covering a lot of different topics, and we came out with about 3.7 different optimization efforts currently underway at different stages of development within these organizations. So it's not just a fixation on one particular process. There's a lot of different anticipation that these QC-based optimization efforts have wide applicability across their entire business chain. This is just some demographics in terms of who we talk to. I always like to show at least, so can you believe what you're hearing a little bit? This is basically a breakdown. We ended up talking to 6 major nations: United States, the EU, and then the UK, if you will. Maybe UK at some point will come back into the EU. I know they want to. We identified in conjunction with D-Wave the 10 target industries that we really wanted to look at, and that turned out to be about 78% of the overall respondents. And these are the 10 target industries that we covered. I'll show you the secondary ones later. How do we define secondaries? Any industries that responded that weren't in these top 10 target industries. And this just shows a little bit about, again, the same breakout. The target industries really kind of correlate with what's going on in our overall survey. These are the developer line of businesses of the organizations we talk to. Again, the key here isn't kind of squinting to see all the numbers. There's, I think, 18 different sectors here. The key here is that we were able to find organizations in just about every sector we could think of that's interested in looking at QC-based optimization efforts. So it's not as if just the finance guys, just the software guys, just oil and gas are interested. There's broad applicability here. We didn't have any trouble isolating. We didn't have to go out and say, oh my gosh, we didn't get anybody from CAE. We need to go find them. These guys were easily identified in terms of, yeah, we're interested in doing this. This is just a quick recap of what I said earlier. Again, the emphasis here is that 60% of the organizations we spoke to self-identified as either a primary or mixed enterprise shop with some HPC thrown in. Simple question, you always ask it first. How important is quantum-based optimization in terms of your overall corporation's perspective? 61% very important, 36% somewhat important. That gives you a right number. What I found interesting is only 1% saw it as too early to tell. So sometimes you'll look at new and evolving technologies, and people say, well, we're really not convinced yet that it's time to pull the trigger. We're not really interested in exploring this. We're not a FOMO company. We're not a traditional early adopter company. We're going to sit on the sidelines and wait. Everyone we spoke to, every organization except for 3 of them said, yeah, it's not too early to tell. We're ready to pull the trigger. So let me just give you a little detail based on that summary I gave you. Oh, by the way, let me just add, all these slides will be available. I don't know how D-Wave's going to make them available, but at the end I'll be giving my email address. If you want the slides, just drop me an email. And the only thing I ask is if you have any complaints or issues or comments about what I say here or in the deck, that's the price you get for having to write me and say, please send me the deck. And then you write back and go, oh yeah, well, I didn't like slide 18. So the slides will be available from either me, and I assume the D-Wave folks will make it available as well. So when we asked a little bit about the most important business process appropriate for QC optimization, finance-oriented optimization, supply chain management, manufacturing process, workflow schedules, you can see that this is the wide list of all the business processes that we offered up to them. And again, what you'll see is finance-oriented optimization was hit by 17%. Oh, nice. But the wide range of what organizations saw as being a potential most important business process is pretty broad. Almost nothing that we offered up was viewed as really not all that interesting. So that basically gives you this sense that there is a wide base of interest here across a wide range of different kinds of business processes. This just was when we asked the question later and we say, okay, now that you picked the most important, pick all the ones that apply. And the reason I like to ask this question is this is where you get this number of, it's not just one thing that we're looking at, it's many things we're looking at. You can see here, the numbers kind of de-evolve, if you will, into kind of a gray goo of cloud where everyone is saying, yeah, if I can pick 3 or 4 different choices, we have a wide range of opportunities here. So you have the most important ones that were on the previous slide, and this is the ones that say, pick as many you think apply. And what's interesting here, of course, is you get that 3.7 average activity selected per respondent, showing again the broad potential viewed for this technology. When we ask about the status of their most important, because we said, okay, now you've got the most important one, key in on that one, what's the status of that currently or within the next 12 to 18 months? And what we found that was about, if you look at production use of quantum computing, the second one about 21%, that's where we kind of get that 1 in 5 right now. We're using a production class capability in quantum. Certainly the largest one at 1 in 4, quantum use case analysis and prioritization. Organizations are looking at different priorities, different opportunities within the company to see what they're doing. So they're really in the analytical phase, but we have some percentage looking at fully funded research, proof of concept research programs, and some limited in-house pilot production. But the key here, I think, is really that 1 in 5 looking at production of quantum right now. I don't know why I'm pointing it like that. This is when we just move again to the pick all that apply. And again, what we saw here is about 2.6 activities selected per respondent. And really, again, what that tells you is there's not one single activity going on. There may be a number of different activities going on within the company. Some of them are in pilot production, some of them are in production, some of them are looking at perhaps proof of concept research programs. So it's not as if a company or an organization is moving in lockstep, and every one of the business processes they're considering is something that that's moving in tandem or in parallel. It's much more diverse. I will mention that one of the cutoffs that we had for this particular thing, and the data is in the appendix, we were a little discriminatory when it came to the kinds of companies we wanted to survey. We were looking for annual revenues of at least $15 million or more, and I believe we had companies all the way up to $10 billion and more participate in this. They had to have a reasonable IT budget of about $5 million or more. And the only reason we picked those numbers is we wanted to make sure that we got hold of companies that not only had aspirations to explore quantum, but had both the overall revenue stream and IT infrastructure to support something a little more realistically. So this really shows that, that the companies that are out there, these are not small organizations that are aspirants. It's not 2 guys saying, hey, this is a great idea. It could be a 10 or 15 or $20 billion organization thinking these thoughts. Again, here we asked the most important business drivers going on here. This is the single most important: enhancing business processes, increasing innovation, increasing revenues, driving innovation, achieving competitive edge. These are all apple pie and motherhood when it comes to really driving business processes. No great surprise here. And then when we asked them about all the drivers, you can see increasing revenue, business processes, and such are also were also important business drivers as well. When we asked about some of their organizational drivers, referring back to what we talked about earlier, potential performance improvements as one of the many drivers, about half said that. The main driver was 17% I talked about earlier. But really the key here, I think, is the fact that you have the influence from both the technical IT staff and the upper management saying, yeah, this is something that we think is really important. So it's really kind of a self-identification that not only is the performance potential been demonstrated, but that message has been delivered to both the technical staff and the C-suite guys as well. And I think that's a really important hurdle to get over sometimes when it comes to introducing a new technology that's a tad more esoteric, perhaps a tad more expensive, and perhaps a tad more unproven. So let's talk about some of the QC-based optimization efforts that we did see going on. And we asked a little about start dates, and we said, how long has it been since you started that most important improvement? And what you'll see here is if you look at some of these numbers, most of the important efforts have been active for about the last 16 to 18 months. So work is going on. And in fact, if you kind of parse those buckets at the bottom that talk about 12 months, 18 months, 12 to 18 months, 12 to 6 months, and such, what you'll find is that about 1/5 of every organization we talk to initiated something in one of those 6-month buckets. So there is a regular cadence, if you will, in terms of organizations bringing in or initiating some part of this, their most important business process, starting as much as more than 2 years ago, 13%, but again, kicking in 20% of the respondents every 6 months. So there's real vitality in the sector in terms of initiating these projects. When we asked about the hardware support to support this most important QC-based optimization effort, what you hear is that QC access currently through CSPs, cloud service providers, are about 40% of the optimization efforts that are going on. Direct access to quantum computing vendors or through a curator, if you will, something like, say, a company like Strangeworks, is about 41%. Now, interesting, 18% say they access through on-prem QC requirements. I don't believe that. I think that number is a little too high right now. If I don't believe it, I can say things like maybe that's their plan in terms of the next 12 to 18 months. We have started to see some really interesting uptake in interest in on-prem quantum computing capabilities. We heard an announcement here yesterday about Huntsville, a company across the river called Qubits just sold a $41 million box to a Japanese research facility, AST. IBM is going to install a system in Riken. IQM is the European community is buying quantum computers right now for end user access in one of their largest, called the Euro HPC project. And they're buying a lot of domestic on-prem capabilities as well. I think we're going to start to see more and more on-prem sites kick in as people think about things like confidentiality or the need to protect data that they don't want flying over the internet. They have pretty rigorous quantum classical hybrid algorithms, which means that the time of flight delays over internet may actually become a substantial portion of your overall time to solution. Or the one that I find most compelling in the near term. When we do surveys about what are some of your major concerns about quantum computing, the phrase lack of in-house expertise pops up an awful lot. About a third of our respondents say, we just don't have the in-house capability we really need. The professional service sector is starting to mature, but I think there's a little bit of progress there that we'll hopefully see in the next few years. So what I'm seeing is there's no better way to understand how a machine works than when it's sitting on-prem and you can play with it and toy with it and bend the rules on it on a 24/7 kind of environment. That's how you learn most about a machine, not if it's held at arm's length through either a CSP interface or even an interface that's being held by one of the vendors. So we think, or at least I think, that some of the interesting drivers of on-prem are going to be the idea that organizations are going to want to build in-house expertise, and one of the best ways to do that is to have a system that sits in the basement that you can really kind of beat the hell out of, that you wouldn't be able to do in a cloud-based, remote arm's length kind of interaction. So then we kind of dove in a little bit about what kind of classical hardware do you see supporting this most important optimization. And when we just said, the first question was, do you think it's going to be cloud-based or on-prem? This was split about 52% said cloud-based, about 48% on-prem. And if you just look at the numbers here, you can kind of squint at it and say, okay, we're looking at about 64 to 256 node on-prem to support this QC activity, or a cloud-based instance is less than, say, running 1 hour per job. So there's certainly some additional overhead, if you will, some additional considerations, the commitment of resources to run those quantum computing systems for the business processes that are going to require a certain amount of dedicated hardware capability. And this at a minimum just gives you a sense of how much the scale is anticipated going forward. Not that either of these things are all that terribly onerous, but they're non-zero, and that's just something to consider in the overall cost of the system. Here's where we get to that greatest hurdles to QC-based optimization. And you notice the first one, this one, every time I ask this question for any technology, if I'm looking about adopting classical HPCs, oh, you want to go GPUs, oh, you're thinking about generative AI and now quantum computing. The big three are complexity with integrating into my workload environment. We heard a little bit today about modality issues. When we ask organizations, we did one a while ago, we asked about what your vendor selection criteria was. Modality was way, way, way at the bottom. Things like qubit counts was way at the bottom. The ones that always appear at the top are, how effectively can you integrate this technology into my existing workload environment in a way that is at least, I'd love seamlessly, but I'd love something that isn't painlessly seamy. So the idea here is that the single greatest concern with a lot of potential end users isn't, do I pick the right modality? It isn't, It isn't, do I like this vendor over that vendor? It's who's the organization that can bring in a solution that merges most effectively with my existing computational workload. And I think that integration issue is something that some vendors are not nearly as far along when it comes to that. They still have a somewhat myopic view about what that quantum computer is and who ultimately is going to use it. And then, of course, I mentioned this lack of in-house quantum computing expertise is a deep concern, and concerns with demonstrating ROI. I'm surprised this number came up this high. Now remember, this was a pick 3 option. So ROI and demonstrating that stuff always happens. But the fact that I saw such optimistic prospects for quantum computing ROI in this study, I'm surprised that came out there. One of the other things that you can't see, and of course this is the power of Microsoft and their ability to show graphics. Slow progress in demonstrated return in demonstrated progress in the traditional computational world. For those who don't know, it is becoming increasingly expensive in terms of dollars, in terms of power consumption, and in terms of complexity of machines to gain performance in the classical compute world. The biggest machines, we've heard a little bit about supercomputers the last couple of days, Oak Ridge, Argonne, Los Alamos. The machines that were just procured in these facilities cost about $600 million a piece. And their ultimate total cost of ownership, when you start to factor in things like energy costs, you may be looking at a 5-year TCO of about $1 billion. That's out of the reach of just about anybody but some of the most aggressive government programs around the world. And that's just to get, in some sense, incremental performance gains. The ability for these machines to double their performance every year, something that they have done for the last 40 years, is really starting to tail off. And those performance gains are more expensive in so many different ways. So there's a lot of concern right now about what's the next big thing going to be in computing, because the classical world is really, in some sense, running out of steam in their ability to deliver traditional performance gains. It's why we saw so much interest in GPUs. It's why everyone has their fingers crossed for generative AI. And it's why everyone is looking to quantum to help alleviate the slowdown in return on investment from a computational performance perspective in the classical world. Let's jump a little bit into optimization developers' budgetary perspectives. We asked them about, okay, how much are you going to spend in the next year, the next 12 months from the day you fill out this form? And you'll see that about 1 in 5 said, oh, we're looking at about a $5 million commitment. 1 in 9 said more than $7.5 million. But there was no consensus about a typical budget. And you can see the histogram here is relatively widely distributed. But the nota bene about all this thing is that this budget includes both QC sector revenues, the things that QC vendors, hardware, software, services, professional assistants and such, in addition to the in-house expenditures to support a quantum computing-based optimization program. So it's you have to have in-house personnel, in-house resources. You have to commit, in fact, data center floor space. You have to bring in subject matter experts. You have to bring in programmers and other expertise to do this. And so this is kind of the 12-month budget. But again, the key here is it's not only QC revenue-facing numbers, it's also what gets expended in-house to support that. So here we get to this rather strange phrase, which I keep explaining to people because I'm not very clear about it, is steady state annual budget. It's like when you turn on a circuit and you get this pulse of energy and all things happen, and then eventually it quiesces into this wonderful steady state when you finally get the computer up and running and the CPU utilization drops down to 3%, life is good. So we wanted to say when life is good, when you've actually got a production level quantum system up and running, and it's dealing with your most important business QC-based optimization efforts, what do you anticipate spending every year on that particular operation? About 1/3 said, oh, between $1 million to $5 to $7 million. 1/4 expect to spend more than $10 million annually. And about 15% of US respondents are looking to expend more than $25 million annually to support their most important steady state QC-based optimization activities. So then we said, okay, what do you think this ROI return is? And here we define a ROI as the sum total of all additional money owing to greater operational efficiencies, increased revenues, increased competitive advantage, realized cost savings and such. And about 1/3 expect $100 million or more annually in that kind of increased savings or return on investment, if you will. And as I said earlier, that represents a total revenue increase of about $51.5 billion per year for the 290 companies that responded to this question. Now, here's the chart I worked a couple days on, and let me just explain it. What this does is it shows the relationship between the expected annual budgets, that's your x-axis that we talked about 2 charts ago, and on the y-axis is basically what your expected annual revenue increases. And this is a 3D chart, so the height, you can see the 0, 5, the 5 to 10, and the 10 to 15 kind of gives you the height of what those answers were selected. And if you just clearly eyeball that kind of orange section there, you'll see that basically it centers on about $3 to $6 million worth of annual expenditures, and you get a resulting revenue of about $60 to $65 million. So you can do your own kind of work here. I kind of like that. I feel like there's almost a linear progression here at some level. There's a reasonable straight line, but I would be remiss if I didn't point out the fact that on the top right there, that greater than 35 million, greater than $1 billion number did show up in a number of different organizations. In fact, I think we came out with 1 in 10. There was only about 9 companies up there that was really looking for some significant kinds of return on investment here for what I consider to be a relatively modest expenditure to support the effort in-house. So really this gives us that ROI number of approximately 10 to 20 to 1 for an ROI investment. But you can kind of play with this chart if you want to look at it and dig a little deeper going forward. Nowadays, you simply cannot talk about anything in the IT world without putting the letters AI somewhere in the process. So we asked a little bit about how quantum and AI combining forces on optimization efforts. And I think we've already seen it here in a number of talks and demonstrations. Yeah, that's a really interesting process, and people are already starting to explore the confluence of those 2 emerging nascent technologies. And so this chart basically says, yeah, that's about right. We see lots and lots of different activities ongoing right now in terms of what's going on in terms of combining quantum computing and AI for QC-based optimization efforts. So this just really shows that AI is on everyone's mind right now, but people are trying to bring the quantum capabilities in a nice hybrid synergistic effect going forward. So this just kind of proves that, AI once again has kind of captured the imagination of everyone, mainly because it's a much more near term. It's got some interesting performance capabilities, and it seems like people have an endless ability to supply money to NVIDIA to buy what seemingly is much more, we're talking $40,000 components nowadays, so you can get a 2 kilowatt chip that's going to completely heat your data center if you get more than a couple of them, but that's my opinion. So bottom line is when we said, okay, really, let's talk about commitment to all activities. Most organizations do plan to move forward with 1 or more of their current projects. So there was a reasonable amount of enthusiasm, as I said earlier. It's not too early to tell. Basically, there's optimism. There is a perceived value added to this capability, and it seems that this quantum-based optimization process has applicability across a wide range of business practices. So here's some summary, and I actually have 3 minutes for closing thoughts as well. So again, this is the part where I tell you what I told you. Study basically says that there's a wide base of organizations exploring the potential. Commercial organizations are convinced quantum systems can accelerate critical business processes and committing significant funds to do so. And the key here is that commercial end users will be looking carefully to address the hurdles that I addressed, integrating QC capabilities into classical ecosystems from a hardware and software perspective, difficulties with navigating a lack of in-house expertise, unclear vendor selection criterion, still hard to pick who's going to be a winner, who's going to be a loser. I know there's some favorites out there in this audience, rightfully so, and how you manage some of the longer-term viability concerns of the sector writ large. Is there a quantum winner coming? Most of us don't think so, but oddly enough, it was someone from D-Wave many years ago when I asked them about the specter of a quantum winter, and the answer I got back was, I have no idea if there'll be a quantum winter, but I'm preparing for one. I thought that was the most prudent advice I'd heard. So vendors can mitigate these concerns. Who can mitigate these concerns? Stand the best chance of really being successful in going forward. So that's my email address, and as I said, some closing thoughts and things I've heard here in the last couple days, which I think are interesting. Bifurcation. I heard the word bifurcation a few times yesterday, and I think that's not the most accurate way to do this. Quantum and classical are not 2 separate islands. Quantum is another tool in the toolbox of advanced computing capabilities. So don't make the mistake of thinking quantum is separate. There's no bifurcation here. This is all part of the eternal struggle to achieve computational capability in whatever it takes to make that happen, whether it be Seymour Cray's vector machines, whether it be Jensen's GPU systems, whether it be OpenAI's generative AI, or whether it be D-Wave's quantum system. It's all part of the same goal. I need more compute capability. I haven't heard really much about real-time optimization, the idea of classically intractable. Classically intractable to me always talks about, oh, it takes the age of the universe. But when I look at optimization, I think of classically intractable as, I think of the Mike Tyson line when asked about a strategy for an upcoming fight. He said, everybody has a plan until they get punched in the face. And to me, you may have a wonderfully optimized schedule for docking planes at Frankfurt Airport. Planes come in, we're going to go to this gate, we're going to go to that gate, and it's perfectly optimized. And then one plane takes off 10 minutes late, and your entire optimization scheme goes out the window. Real-time optimization there says, maybe I could compute an optimal gate landing scheme on a classical system, but that may take 5 hours, and by the time that's done, I've completely messed up my entire last 5-hour schedule. Quantum can bring real-time optimization. It's creating a solution that is otherwise intractable in a narrow time frame. And I think that that's an underappreciated aspect of all this, is the near real-time capability for a lot of these things, because, like Mike Tyson said, most optimization plans are great until someone gets punched in the face. And I think that's an underappreciated asset here. The last one I just want to talk about here is, I've heard the bar is high compared with traditional technology. I don't think so. I think that the early adopters of any technology, again, the overwhelming emphasis is on performance, and Shor's algorithm is only 30 years old. Navier met Stokes almost 200 years ago. So the bar isn't high, it's just that the classical world has been around so much longer. We have so much greater expectations for it. And so I think it's more about managing expectations than it is saying, how does quantum compare to classical? Classical's had over 200 years. There's a great example that says that the Chinese may have been doing Gaussian elimination over 2,000 years ago. So that algorithm's been around for a while. So give it some time. Be a little more forgiving when it comes to quantum. I notice no one's talking about error rates when it comes to ChatGPT. I think maybe we should start thinking about error correction there before we start beating ourselves up about our own industry's capabilities in error correction. Well, I've run out of time, so there's my email address, there's my Friedman Dyson quote that I really like, and I want to thank everyone for listening. And I'll be around for the rest of the day if you have any questions.
So you can, I'm going to ask you a couple questions.
Oh, sure, yeah.
Okay, great. So we're going to keep Bob on stage. And we've got Susan loaded with the microphone. So go ahead and raise your hands if you've got a question. I have a question prepared, so if you want some time, but anybody who's really fast with their hand up. And I'm an extrovert, so I've also learned to count in my head 8 seconds to give people a chance to think and be like, okay, I want to contribute something. Okay, so I'm going to start with my question. So Bob, in terms of the change in people's expectations about sort of like the uses and benefits of quantum computing, one of the things that's happening is that the technology stack has become a lot simpler to use. Right? We've got classical computing, we've got hybrid computing available, we've got cloud APIs. Do you feel like some of the changes that are taking place over a slightly longer period, like 2 or 3 years, are partly because our expectations are changing, so we're asking different sets of questions, or is it also that it is an underlying pattern of people's expectations changing?
I would say that the quantum sector, the supplier base in the last 3 or 4 years has done a great job in terms of managing expectations, rolling out roadmaps, and addressing issues that matter. So it's no longer, here's a machine, knock yourself out. It's support with professional services. It's demonstrated performance gains. So you're not saying, I have X number of qubits. You're saying, look what we did on this particular application, how we accelerated this performance. So it's really, in some sense, about the sector managing expectations. It's why I love roadmaps. It shows commitment, it shows measurable progress, and it says, this is where we are today. When we were back here, we said we'd be here, and we hit it. So when we talk about where we're going to be in a few years, you have increased confidence. So I think the sector has done a very admirable job in maturing. In the stack is really becoming much more subtle and more sophisticated. And I get this newsletter every week from a guy named Travis Humble at Oak Ridge.
I get that one, yeah.
It's great. He admits he does it in his kitchen table on Sunday mornings in his pajamas. Subscribe to this newsletter. It's out of Oak Ridge. But I wanted to start to do a word count, because the word I see most frequently now is partners. Companies are partnering now. The quantum computing organizations are looking to fill gaps and to partner with end users to make their products more amenable to the use cases at hand. It's no longer, if you build a machine, they'll come. It's, let's all build a machine together and everybody wins.
Yeah. Part of that sort of whole product solution. I mean, and also making sure that you make it easier for people to onboard. The easier it gets, the wider the community we can engage. And I appreciate that point about like a consistent track record of delivering systems. That's definitely been on our mind at D-Wave. Okay, I've got another question, but I'm going to do another call here. All right.
Bob, I saw one of your presentations from about a year ago. And again, on this one, you say professional services companies have a role to play. I work for one of those. What is your message? How do they actually go about understanding this deep technology and going confidently to their clients along with a partner to say, we will try something out for you? What is the message? How do they actually go about it, even though they have no expertise in-house themselves and they can't invest very much other than maybe a handful of employees who are interested and have the capacity to understand? What is the pathway for that?
I can't hear it.
Yeah, the question here is that for a professional services company that's going out and approaching their clients and they're trying to initiate that effort. So even within the professional services company, they have a small number of people. What is your advice for like, you know, what the client, the customer is expecting to hear from them? How do they go and create that interest in their end clients?
To me, it's very simple, and it applies in the HPC world writ large. What are your most compelling workloads? What bothers you the most? Where are your shortfalls? Where can we apply the most leverage to improve your overall process by looking at some key weaknesses in your existing workload capability? And so and then how can that be accelerated by quantum? You can't just come in and say, we're going to quantize everything you've got. You have to find the linchpins. You have to identify the workloads that matter most and go after those with unglaring optimism and focus. And to me, that's what you have to do. You don't go in and you say, here's a solution. You go in and you say, what are your problems? Mm-hmm. And that's the first step. And then you bring quantum to bear on those solutions.
Yeah, kind of like I was hearing Lorenzo talk about yesterday in the customer success journey, is understand your customer and talk to them to make sure that you're able to kind of do that active listening and kind of hear where their pain points are, and then talk to them about the applicability to those pain points. So, and exactly why it's so important for us to be working with all of you, because I'm sure you're all in that experience. You get like dozens of emails a day of cold calls. It's really the relationships that you build and the people that you know. And so that's your opportunity to like understand their space and their problems and build a solution in it.
Yep, and always speak about performance gains. That matters most. We do a survey of end users every couple of years, and it's basically, what does it take to get you involved in quantum? And the answer is always, we don't hear things like quantum supremacy, quantum advantage, quantum whatever. What we hear is, man, you give us 20x performance gain on this application, the checkbook comes out. Right. 20x in the classical world nowadays is a 2 or 3 or 4 year advantage in compute capability. You translate that into a competitive advantage with an organization down the street that's not quantized, you've got a major hit there. So you're looking, like I said, 20x performance gains on your most compelling application. The argument is over. And by the way, if you do it in the kilowatt range, instead of the megawatt range, the machine pays for itself in 6 months anyway. Yeah,
you said 2 kilowatt chips. That's a 10 orders of magnitude difference with the quantum computing chips. Okay, any other questions? We have a question out here, Ron.
Hi, you mentioned a number of companies back in the 80s, like Floating Point Systems, Nova General, Digital Equipment Corp, even a company named Gould were making high-performance computers. None of them are around anymore. Do you have any insights as to what they did wrong and what companies today should avoid doing?
Well, first of all, I'm going to argue that some of them deserve to die, okay? Cray is still around. You can still buy Cray out of HPE. The point, though, is that with any new technology, you're going to see flux. You're going to see new ideas come to the fore. The sector has to evolve. And so it's not as if you're going to be able to pick a winner or a loser today that's going to be a business 30 years. It's about that company's ability to pivot over time, to adjust to the evolving technologies, to meet the compelling workloads. But to me, when companies come and go, present company accepted, that's all part of the business here. That's how the world works. As long as you have enough companies entering and leaving at reasonable same rates, you're going to get refresh new kinds of ideas. And also consolidation is the key here as well. I don't think we're going to have as many quantum computing makers out there as we have now in the next, say, 5 to 10 years. I certainly don't think there's a place for every modality that I see out there. And so in my mind, it's going to be the organizations that can demonstrate use case capability, not modality or qubit counts or T1 times and such. But this is the nature of the beast in every new technology in IT. There are winners. I mean, we're down to how many microprocessor companies nowadays. There used to be many. My first code I wrote on a Mostek 6502. Most people don't even know what Mostek is, but it was in the Apple. It was in the Apple II before they went to Motorola, who doesn't do microprocessors anymore. That's the nature of the beast. I wouldn't lose any sleep over it.
More questions? Here we go.
Thanks very much for a great presentation. This might seem like a somewhat naive question, but you talked a little bit about organizations that were looking at bringing the technology in-house and having it on-prem. One question is, when you look at kind of the computer and a lot of the cost is in the fridge, what will be the upgrade paths, or will there be any upgrade paths? So, in a year's time when there's, 50% more qubits, would that company be faced with buying the entire installation again, or would there be upgrade paths?
I've talked to a few companies that have grappled with, how you arrange an on-prem capability. And I think what you're going to see, because the sector is moving fast, I always like to say there's nothing more obsolete than a 4-year-old quantum computer 4 years from now. And so there are going to have to be some it's not going to be a lease where the machine gets pushed. It's not going to be a procurement where the machine gets pushed out the door and you never hear from the vendor again. There's going to have to be things like incremental upgrades, technology refreshes, and all sorts of things that allow a vendor and a potential on-prem customer to basically adopt new technology as it goes forward. I don't see any other real way to do that. And the HPC world does that all the time. System refreshes are a standard way to do business with new technology. Sometimes they literally can come in and just pull chips off a board and put a new chip in. I see the quantum computing world being sophisticated enough to understand that, yes, this is not a one and go kind of installation. This is going to be, at least for the near term, this is more of a partnership than it is a customer-client relationship.
And we've, at D-Wave, we've had experience with that as well, because our longest customer at the University of Southern California and ISI, working with Lockheed Martin, they had a D-Wave 1. We've got 5 generations of quantum computers we've upgraded there, and generally, just like you're saying, we're avoiding like a forklift upgrade and actually just only upgrading the components that switch. So with that, thank you very much for your questions. Thanks again to Bob for entertaining us.
No problem. Always good.
Insightful talk.